easier side, students, and then we'll go for the other unsolved problems, students. Now, when you speak about students, impulse, I made it very clear. Impulse is that maximum force which is acting on a body for a very short interval of time, students. And we know that impulse, students, is a vector quantity, variable j bar, and it is the maximum force which is acting on a body for a very short time interval, students, we consider. Okay, and that's what we call as impulse. Its unit is always we consider as Newton seconds, students. So how's force and time? It's a product of force and time, students. So it's a inverse variation, students, we consider. Now, suppose if in case if I ask you a question, student. Students, I want you to get me the answer for the force exerted by the wall. So the force exerted by the wall on a car moving with a velocity of, students. Okay. A car traveling at 4 meters per second is brought to rest in 2 seconds when it strikes a wall. Students, a car I'm giving it to you whose mass is given to you as 2 into 10 raised to 3 kilograms. Traveling at 4 meters per second and it's brought to rest. And brought to rest, students, in 2 seconds. When it strikes the wall. When it strikes the wall, students. My question is, what are the force is exerted by the wall? Yes, can you answer, students? It's a very simple question, students. So is this a question clear to all of you all?
Yes.
Okay. Yes, anyone?
So is the answer negative?
No, my dear. Swapnil has got the answer. It's an easy question, students. Yes, Ashmita. Priya, what about you? Ashmita, Mayur, Jason, Nishant. Nishant, are you back or you're still over there only, Nishant? Oh, still man, Nishant, but I feel like that your studies are getting affected, it seems. Because at times I could see that because of time difference or whatever it is, you're not able to at times attend lectures. I know, fine, Nishant, you can't unmute, I know. See that you focus yourself up, please. Ashmita, can you answer, Ashmita? Absolutely correct. Yes, Swapnil, can you tell me how to go about?
Yes, sir.
So
Double.
by using impulse, it means to change in linear momentum.
Okay. So impulse, you mean
Yeah.
to say, is simply change in momentum we consider. So change in momentum is equal to F into change in time. And change in momentum, you mean to say mv minus u. Is this what you mean to say?
Yes, sir.
Okay, absolutely correct. How much is the mass of the body is given to us? 2 into 10 raised to 3 students. Final velocity is 0 minus what is the initial velocity?
0.
Initial velocity is how much?
0.
So,
0.
No, no. Sorry, sir. That's 4, 4, 4.
Initial velocity minus 4. Friends, if in case if I speak about this is all in vector notations. Okay, great. Question क्या पूछा था? Force exerted by the wall. So the force exerted by the wall will be in positive. Are you getting it? Is this clear, students? Are you getting
yes,
this
sir.
part? And how much is the force applied? And what exactly the change in time is given is how much? 2 seconds. So solving it, this will get cancelled. So what's your answer? 4 into 10 raised to 3 Newton. Look over here, students. Is force a scalar or vector quantity? It's a vector quantity. Can I say it's directed by the wall onto the car and its direction will be in this? It's a reaction force. Since it is in the direction opposite to the motion of the car, the force exerted will be in positive. It's along positive x-axis. And this is along negative x-axis. Look at the diagram. You have to focus on the diagram also, students. क्या ये clear हुआ, students? Is this clear to all of you all?
Yes, sir.
Students, do take care while solving problems. You might find out that they are easy. Like in suppose if I would have given in terms of I and I cap, my answer would have been an I cap. Then things would happen in terms of plus. Clear? Ashmita, clear?
Yes, sir. Clear.
Okay. Swapnil, what about you? Mahang, Swapnil,
Yes.
clear? Sure. Okay. Can I raise this question, students? मैं इसको erase कर दूं अभी?
Yes, sir.
Yes, sir.
Excellent. The next question, students. A ball of mass m traveling with velocity, a ball of mass m, and it's traveling with a velocity of 2i plus 3j, receives an impulse of minus 3m I cap. A ball of mass m travels with a velocity of 2i plus 3j, receives an impulse of minus 3m I cap. My question to students, what is the velocity of the ball immediately afterwards? Velocity of the ball immediately afterwards. Hope the question is clear, students. I repeat the question, students. A ball of mass m traveling with a velocity of 2i plus 3j receives an impulse of minus 3mi. What is the velocity of the ball immediately afterwards? Is anybody, students?
So minus I plus 3j.
Minus 5
Minus
or
I plus 3j. Minus I
minus
plus 3j.
plus 3j. Is that what you mean to say?
Yes, sir. Minus I cap plus 3. So no. Minus I cap
Okay.
plus 3j cap.
Okay, absolutely correct. Absolutely correct. Since your formula is impulse is what? Impulse is simply we can consider as
Change in
change in
momentum.
absolutely correct. So it's v minus u. That's all. What is j? They've given to you it's minus 3mi cap, students, is equal to m in your bracket. What they're trying to find out velocity immediately afterwards. That means they're trying to find out the final velocity. What is the initial velocity is given to you as? It's 2i plus 3j. Is that clear? Since this m gets cancelled, so minus 3i is equal to v bar minus 2i minus 3j. Taking this entirely on the other side. So v bar is equal to minus 3i plus 2i plus 3j. So your final answer will be minus I plus 3j. That many meter second inverse. Is it clear? Can I erase the students?
Yes, sir.
Next question, students. Students, it's given to you that a bullet of mass 10 raised to minus 3 kilogram. Okay, given to you that bullet of mass 10 raised to minus 3 kilogram strikes on an obstacle and moves at 60 degree to its original direction. Strikes to and moves 60 degree to its original direction, students. If its speed is made to change, students, if its speed is changing from 20 meter per second to 10 meter per second, speed changes from 20 meter per second to 10 meter per second, students. Find magnitude of students. Find magnitude of impulse acting on the bullet. This is a question clear to all of you all.
Yes, sir.
A bullet of mass 10 raised to -3 kilograms strikes to obstacle and moves 60 degrees to its original direction. Speed changes from 20 meter per second to 10 meters per second. Students, find out the impulse, magnitude of impulse. Miss, come on. Sure, Prag, Pratham, Prajwal, Purvi. Nishant, if you can answer, kindly type it in that case. Nivedita. There are two Krishnas, one from TP, one from Borivali. Kevin, Jainesh, Jason, Aryan, and Shakash today. Smith is absent. Vansh Mehta, Mayank, Bhumi, Ria. Students' question is magnitude. Mayank, can you tell me what exactly your approach is, Mayank? Mayur? Shub? Yes, Swapnil, can you tell me how to go about? Ashmita, any one of y'all? Nishant? Okay, Swapnil is trying. Ashmita, what about you?
I'm not getting it. The answer.
Okay, students, shall I solve it for y'all? Swapnil, Ashmita, because y'all two are replying. The rest of them are just zipped. If y'all two say yes, I'll solve it for y'all. You want me to solve it?
Yes, no.
Ashmita, see one thing. When you look at this question, पूछा है impulse. Now the impulse का मतलब change in momentum तो सही होगा. तो फाइनल मोमेंटम माइनस इनिशियल मोमेंटम करना जरूरी है कि तुम्हें इम्पल्स पूछा और फिर उसका मैग्नीट्यूड चाहिए. यानी तुम क्या करो, तुम आंसर वेक्टर फॉर्म में लिखो ना इसका फाइनल आंसर, फिर इसका मैग्नीट्यूड निकाल दो. Now to get this question more easier, students just try to go for a simple vector notations ka diagram. Think in form of a vector part of it, students. The body is of mass 10 is to minus 3 kilogram and strike. Students, so consider this is an object of mass 10 to the power of minus 3 kilogram, students. Okay, it strikes to an obstacle moving at 60 degrees. Now there is an object in its path. Students, think as if there is an object in its path. It hits, are you getting it? It hits and moves 60 degrees to its original direction. Students, ये इसका original direction था. ये hit होके it will go to 60 degrees, students. So if in case if I happen to go for it, this is 90. 60 degrees from here, if I happen to consider, so this becomes my direction. Agreed, students? क्या ये clear हुआ, students? 60 degrees to its original direction. Students, ये diagram clear हुआ?
Yes.
Yes.
Speed change क्या हो रहा है? Speed is changing from 20 meter per second to 10 meter per second, students. Agreed? So if I say 20 meter per second, then that's the initial speed. Initial speed is along, if I say u, it's along which axis? It's x-axis positive. So can I say it's plus 20 I cap meter per second? And it changes from 20 to 10. So can I say this is your final velocity, which is 10 meter per second? Agreed? But now I need to get my answer in terms of its component, because it's at an angle of 60 degrees with the straight path of it, students. तो अगर तुम्हें ये v दिया तो can I say this becomes v cos 60 I cap, ये होगा minus v sin 60 j cap. Agreed? So what is the final velocity?
sir.
ये तुम्हारा initial है. What is the final velocity? The final velocity will be equal to what? So the final velocity will be equal to what? It's 10 cos 60 I cap minus 10 sin 60 j cap. क्या ये final velocity मिला, students? हाँ students, ये initial और ये final. क्या ये part clear हुआ students आपको?
Yes, sir.
बस अभी तुम्हें impulse चाहिए. What exactly impulse? Impulse is equal to m into change in velocity, students. What exactly go for impulse is equal to mass is given to us 10 raised to minus 3. And what exactly change in velocity I can consider it's final. So it's 10 cos 60 I cap minus 10 sin 60 j cap minus 20 I. Students, is that clear? Now solving this 10 raised to minus 3. What is 60 tan of 60? So what is cos of 60 degrees, students? Cos of 60 कितना होगा? It's
Half.
root 3 by 2. Sorry, cos 60 is half, so this will be 5i. Since this is 5i and this is minus 20i, so can I say this is minus 15i? Agreed? इन दोनों को solve करूंगा तो sin 60 कितना होगा? root 3 by 2. So that will be 2 5s are 10. So can I say that becomes minus 5 root 3 j cap. Since this is my impulse in vector notation, I want to find out magnitude. तो क्या करोगे? क्या करोगे? Students, if I'm getting r bar as rx I cap plus ry j cap, how do we find out magnitude in vectors? Under root rx the whole square plus ry the whole square. आया ना? Students?
Yes, sir.
तो वैसे इसका मैग्नीट्यूड चाहिए तो स्क्वायर कर दो. अभी ये दोनों से मल्टीप्लाई हो रहा है. स्टूडेंट्स लिसन केयरफुली. ये जो 10⁻³ दोनों से मल्टीप्लाई हो रहा है और फिर उसका स्क्वायर करोगे और फिर बाहर निकालोगे तो 10⁻³ बाहर ही आएगा ना. एग्रीड? रूट के अंदर का क्या चला जाएगा? व्हाट एक्जेक्टली यू गेट इनसाइड द रूट साइन? So that will be -15 the whole square plus, solve this and get me the answer, students. Impulse. So is it clear to all of you all? Students?
Yes, sir.
Just solve and get the final answer, students. You should get the answer as root 3 into 10⁻². The answer should be root 3 into 10⁻², students. And since it's impulse, answer should be in Newton second. F into T. ये 300 हो जाएगा, students. So ये 10√3 हो जाएगा. 10 into 10⁻³ will be 3 into 10⁻², root 3.
Yes, sir. Got the answer.
Okay. Students, is it clear to you all? पूछा क्या गया था? See, it is hitting an object and it's deviating its path from the original path by 60 degrees. And the final velocity after hitting it's 10 meters per second. Initial is given to you. And the initial is along positive x-axis we consider. जब भी मुझे magnitude of impulse पूछा तो of course change in momentum मुझे निकालना है. लेकिन final velocity मुझे 60 degree से हिसाब से निकालना ना. So I need to find out its component. Agreed, students?
Yes, sir.
Can I erase this, students? इसको erase कर दो अभी. Students, can I erase?
Yes, sir. Done.
Yes.
Since we have done these kind of questions in laws of motion, students. Hey, students, the next question. Now, this particular question is regarding a particle of mass 2 kilograms, students. A particle of mass 2 kilogram, it is initially at rest. So they've given you that the mass of the particle, students, is 2 kilogram. And initially it is at rest. Okay. A force start acting onto it in one direction. Students, force is made to act on the particle and it's acting in one direction, whose magnitude is changing with time. That means magnitude of force is a function of time. Means now I might give you a graph where I represent force with respect to time. That means force is changing with respect to time. Force is measured in Newton. Time is considered to be in second. So I repeat, students, a particle of mass 2 kilograms initially at rest, okay, moves in one direction, whose magnitude changes, whose magnitude of force changing with time. The force time graph is shown. I'll show you the force time graph. Students, question का पूछा है Find the velocity of the particle at the end of 10 seconds. Now, it's a very simple question, students. I need to find out a velocity of the particle at end of 10 seconds. At the end of 10 seconds, students. Okay. Now, the graphical representation is in this manner. This is 0. This is 2. This is 4. Agreed. This is 6. And this is 10. This force is given to you as 10. And this part is given to you as 20. Students, is the question clear? Yes, Jason, you want to answer, Jason?
So can you repeat the dimensions and units?
अच्छा, स्मिथ अभी आया है, अभी ऊंट पहाड़ के नीचे आया है स्मिथ। क्या क्या डायमेंशन यूनिट्स क्या इसका?
So means units बोलो ना, मेरे को एक बार repeat करो ना.
अच्छा, a body of mass 2 kilogram. The question is a body of mass 2 kilograms. Initial velocity is 0. Okay. A force is acting in one direction and is a function of time. Okay, force is a function of time, students. You need to find out the velocity of the particle at the end of 10 seconds. Force time graph is given to you. Clear, Smith?
Yes, sir.
It's a very simple question, students. Now, Smith has got the answer. Anybody else? Yes, anybody else, students? Why so much of time? Ashmita, why? Jason, क्या हो गया? Nishant, Prachwal, Pratham, Prayag, Smith, you answered. Swapnil, what about you? Shall we discuss, students? Students? Ashmita, shall we discuss?
Yes, sir. So actually, I understood we'll go by area,
Ah,
but the first one is right angle triangle. That will be, and the second is square. But the third one, What shape was that?
Trapezium. It's a trapezium.
Yes,
Third
sir.
one is a trapezium. Fourth one is a triangle.
Yes,
Good
sir.
है. ये trapezium हो गया ना? Half the sum of parallel sides, ये parallel sides हो जाएगा. ये दोनों parallel sides हो जाएगा. Okay, और ये height हो जाएगा.
Yes, sir.
Smith, Smith बताओ सबका area बताओ. Smith, you have done area only, isn't it?
Yes, sir.
Okay, so what exactly the formula we consider is? You have taken the area to be as what? Area of force into time will give me what? Impulse. Are you getting it? And that will be equal to impulse. And impulse is change in momentum. Agreed? M into V minus U. So students, M into bracket V minus U is equal to the area under the graph. Mass is given to us how much? 2. Final velocity पूछा गया, initial 0 है. Now can you put down the area? पहला वाला का area कितना है?
So half into 2 into 10.
So that's 10.
10.
Second का area direct बोलना area कितना है second का?
Second ka 20.
Okay, third का?
30 and fourth ka 40.
Okay, 30 और ये fourth का 40.
Yes.
इसमें तुम area of triangle use करोगे, इसमें area of rectangle use करोगे, इसमें area of trapezium. What's the formula of area of trapezium? Smith, what's the formula for area of trapezium?
Half into
So,
sum of
Yes.
parallel lengths into height.
Absolutely correct. Half the sum of parallel sides into height, and the last one is a triangle. Now just put down the area, students, of all. So 40, 50, 60, 70, 80, 90, 100 हो जाएगा. What is the velocity, students? 50 meters per second. Agreed? Students, is it clear?
yes, sir.
Can I erase it?
1 minute, sir.
So 1 minute.
Students, तुम लोगों ने ये
Yes, sir.
इसमें किया नहीं किया? तुम लोगों ने लॉस ऑफ मोशन में नहीं किए प्रॉब्लम्स? हाँ students? Ashmita, where
Yes.
I'm asking.
Yes, sir, we did. But sir, similar question we did for right angle triangle and one triangle only. So
Fine.
this was like all together, right? That's why.
Yes. Okay, fine. Can I erase now?
Yes, sir.
Okay. Okay, now, students, some more problems onto your impulse, and these are some unsolved problems, students, of your module only. Okay, students, if in case if I tell you a particle of mass 1 kilogram is projected from the ground, students, it's projected out, projected from the ground at an angle of 60 degrees. That means it's impulse with projection, students. Okay, students, you all have your module in front of you, students. Module has तुम्हारे पास में? Module 3 is there.
So page number?
Page number 124, 124. Since page number 124, there are 3 unsolved problems just above collision. I wanted to try out the first one. Students, the question is, a particle of mass 1 kilogram is projected from the ground at an angle of 60 degrees with the horizontal. Students. Okay. So particle is projected at an angle of 60 degrees with the horizontal at a velocity of 20 meters per second, students. Find the magnitude of change in velocity in 1 second. Students, it's a very good question, which you should know it. इसका आंसर आना जरूरी है स्टूडेंट्स. प्रोजेक्टाइल में we have learned as a problem for change in momentum after time t. We have learned about change in momentum from initial position to maximum height. We have learned about change in momentum from initial to final position from ground to ground position. All the students, please, Smith, Nishant, Swapnil, Nishant, all of you all students, we have done these kind of questions. अब यहाँ पे सिर्फ values दिए बस. अगर तुम्हें वो concept आता है तो यहाँ पे तुम निकाल सकते हो आंसर. So I'll just simply draw the diagram, students. A particle is projected. Mass of the particle is given to us 1 kilogram. This is the horizontal, students. And the motion is projectile, students. Okay. It's projected at an angle of 60 degrees with the horizontal, students. After 1 second, students, with the horizontal, and it moves with a velocity of 20 meters per second. So U is given to us 20 meters per second. U is 20 meters per second, students. Maybe if in case if I say after 1 second, the particle has an instantaneous position is this. Let us say V is a final velocity after time t. Agreed? V is a final velocity of the particle after time t. Find the magnitude of change in velocity in 1 second. So in time, 1 second, they're asking you to find out the magnitude of change in velocity. Magnitude of change in velocity, students. Students, hope the question is clear. Yes, students, anyone? Smith, क्या हो गया?
So solving.
स्मिथ आना चाहिए तेरे को, इतना टाइम नहीं लगना चाहिए. पर तूने ये चेंज इन मोमेंटम का क्वेश्चन किया हुआ है when we did projectile ground to ground projection में.
So is the answer 20?
I know, my dear. अच्छा, you are getting 20. Ashmita got 0.2.
So is it minus 20 root 3?
No, no, not at all. Swapnil, अभी निशांत बचा है. तीनों ने आंसर दे दिया. निशांत, are you there? अरे मैंने सोचा नहीं था कि ये क्वेश्चन तुम्हें इतना awkward लगेगा. तो निशांत got us 20. Okay, students. Shall I start? Mass is 1 kilogram, students. Mass is 1 kilogram. Only asked is change in magnitude. Shall I start it for you all, students?
Yes, sir.
Okay, students. The question is on page number 124, students, and it's the first question, okay? Now please pay attention, students. The body is projected. Suppose ये ground से project कर रहा हूँ और यहाँ पे इसकी initial velocity is given to us 20 meter per second, students. So can I write down its initial velocity in vector form, students? The initial velocity in vector form, if I happen to consider, then what exactly it will be? Then you will say, sir, it will be u cos 60 I cap plus u sine 60 j cap, students. So what's the initial velocity in vector form I'll consider will be? It's 20, cos of 60 will be half. Agreed. Plus u will consider as 20 sine of 60, that is root 3 by 2. So what exactly my initial velocity I'll consider will be equal to 10I plus 10 root 3 j cap meter per second. Students, is this clear to all of you? Students? Students, क्या ये clear हुआ?
Yes, sir.
अभी प्रोजेक्टाइल के अंदर स्टूडेंट्स अगर प्रोजेक्टाइल का मैं डायग्राम बना स्टूडेंट्स, लेट मी गो फॉर स्लाइटली बिगर वन. अगर ये वाला डायग्राम मैं लेता स्टूडेंट्स, सोचो कि 1 सेकंड के बाद में पार्टिकल यहाँ पे आता है स्टूडेंट्स, यानी आफ्टर 1 सेकंड अगर पार्टिकल यहाँ पे आता है तो स्टूडेंट्स मुझे बताओ क्या क्या हॉरिजॉन्टल does the magnitude and the direction of the horizontal velocity goes on changing? Students, for projectile?
No.
No, तो ये तो हमेशा u cos 60 होगा स्टूडेंट्स, है ना? The velocity after 1 second be v, students. This v is actually nothing but it's vx plus vy. है ना? Vector form में.
Yes, sir.
Clear? So now if I want to write down my final velocity, students, तो मेरा vx क्या है? u cos 60 होगा. I cap. मुझे vy नहीं पता, students. I don't know vy. Can I find out vy? Students, can I find out vy? Why not? Formula क्या है? So for Vy, can I use the formula V is equal to U plus AT, velocity along y-axis, initial velocity along y-axis, acceleration of y-axis in time t? I get तुम्हारा formula. So can I say velocity along y-axis? What is the initial velocity along y-axis? Students, what is the initial velocity along y-axis? It's U sine 60. Yeah, U sine 60. So it's U sine 60 in time 1 second. Acceleration along y-axis is minus g in time 1 second. Agreed. Students, what's the velocity along y-axis? Students, what's the velocity along y-axis? Velocity along
G is
y-axis.
given 10.
Pardon?
G is given 10.
Yeah. So now I'm putting it back over here, students. So this will be u sine 60 minus g, and that is along y-axis. So can I say j cap? क्या ये clear हुआ सबको?
Yes, sir.
Students, क्या ये clear हुआ सबको? Then I'll move further ahead. Otherwise, सब
Yes,
लोग
sir.
I don't want to push
Yes,
myself. It has to be very clear. अभी मुझे क्या चाहिए? चेंज इन वेलोसिटी चाहिए, बस ये पूछा, मास की जरूरत ही नहीं है. हाँ, अगर मैं इम्पल्स पूछता यहाँ पे तो मुझे मास से मल्टीप्लाई करना पड़ता, जो कि चाहिए नहीं मुझे. I getting it? मुझे अभी चेंज इन वेलोसिटी, व्हाट एग्जैक्टली चेंज इन वेलोसिटी? सर चेंज इन वेलोसिटी अगर आपको चाहिए तो दैट इज फाइनल माइनस इनिशियल. तो स्टूडेंट्स इसका आंसर क्या होगा? अगर मैं फाइनल देखूं तो इसका आंसर क्या होगा? सर ये है u इज हाउ मच 20. तो कैन आई से फाइनल u is equal to how much? Sir, it's 20. Cos of 60 will be equal to how much? Half. So can I say this is 10i plus sine of 60 is root 3 by 2. Agreed? So that will be how much?
Yes.
10 root 3 j cap minus g j cap. This is final minus initial. तो ये माइनस में आएगा 10i, ये भी माइनस में आ जाएगा. So what exactly change in velocity in vector form? So ये कैंसिल हो जाता है, ये भी कैंसिल हो जाता है. बचा क्या? है ना? मुझे क्या पूछा है? मैग्नीट्यूड. अच्छा आंसर 9.8 मीटर पर सेकंड.
10 no?
जी अगर 10 है तो 10 ले लेना है, लेकिन अगर नहीं दिया होता तो 9.8.
दिया है इसलिए बोल रहा था 10.
हाँ क्या बोल रहे हो?
सर ये दिया हुआ है 10 इसलिए.
अच्छा दिया हुआ है 10. ओके सो आंसर इज 10 मीटर पर सेकंड. जी इज गिवन टू एस 10 मीटर सेकंड स्क्वायर. फ्रेंड्स क्या ये क्लियर हुआ सबको?
Yes, sir.
Yes, sir.
और स्टूडेंट्स में क्लियर हुआ?
Yes, sir.
तो कहाँ गलत जा रहा था?
So मैंने वो सेकंड लास्ट स्टेप में से उधर से रॉन्ग कर दिया. मैंने 10 को कट करने की जगह मैंने प्लस कर दिया, इससे मेरे को 20 आ रहा था.
ये ऐसा सेम एग्जैक्टली सेम क्वेश्चन प्रोजेक्टाइल में हम लोगों ने किया है स्टूडेंट्स.
मैंने तो 10 minus 10 2mu sin theta करके किया था.
अच्छा हम लोग ने ऐसे किया है स्टूडेंट्स. ग्राउंड से इन टाइम टी कितना, यहाँ पे हम लोग ने वेलोसिटी निकाला है. फिर हम लोग ने चेंज इन मोमेंटम यहाँ से मैक्सिमम हाइट के लिए भी निकाला है. हमने चेंज इन मोमेंटम फ्रॉम ग्राउंड टू ग्राउंड भी निकाला है, इनिशियल एंड फाइनल पोजीशन. हमने एनर्जी के बारे में भी लिया है स्टूडेंट्स, चेंज इन एनर्जी के अंदर भी. यानी यही क्वेश्चन वर्क फॉर एनर्जी में भी पूछता है स्टूडेंट्स. व्हेन यू डू वर्क फॉर एनर्जी सो चेंज इन द एनर्जी, काइनेटिक एनर्जी, इनिशियल फाइनल. अगर मैं पूछूं यहाँ से टिल मैक्सिमम हाइट, तो यहाँ पे सिर्फ काइनेटिक होगी, यहाँ पे काइनेटिक एंड पोटेंशियल दोनों होगी. सिर्फ तुम्हें क्या करना है, यहाँ पे एक वेलोसिटी फाइंड आउट करना है. अगर तुम यहाँ पे देखो तो व्हाट इज द वेलोसिटी एट द हाईएस्ट पोजीशन? ओनली हॉरिजॉन्टल u cos 60, u cos थीटा ही होगा. ओके कैन आई इरेज दिस स्टूडेंट्स? इसको इरेज कर दो.
7.
1 minute, sir.
Nishant, you got it? Okay. Fine. Please, when you'll complete, just let me know about it. Change in velocity is final minus the initial, huh, students? And as I've done with first one, students, go ahead with the second and the third one. Second one is easier. Yes, can I erase now?
Yes, sir.
Nishant, can I erase? Nishant? तो अपने अभी दोनों आंसर्स करेक्ट लेगा, सेकंड एंड थर्ड. Velocity of a particle of mass 2 kilograms varies with time according to the equation given to you, students. They've given to you velocity as a function of velocity of a particle varies of time. So velocity is given as v bar is equal to 2t I cap plus 4j meter second inverse, students. Here t is in second, students, and v is in meter per second, students. Find the impulse imparted to the particle in time interval from t equal to 0 seconds. So find out the impulse imparted to the particle in time t equal to 0 seconds to time 2 seconds. Is the question clear, students?
Yes.
Nishan, the question is velocity of a particle. Velocity of a particle whose mass is given to us 2 kilogram. Velocity of a particle of mass 2 kilogram varies with time according to the equation v is equal to 2ti plus 4j meter per second. Here t is in seconds. Find the impulse imparted to the particle from time 0 seconds to 2 seconds. It seems who has got the answer. No, Smith, it's incorrect. Tu ghai kar raha, Smith. Oh, impulse पूछा ना? तूने क्या impulse find out किया है? Wait a minute. Yeah, it's correct. Correct, Smith. Yes, what about rest of your students? Yeah, shall we discuss, students? Swapnil, Mayank अभी आया? Mayank पहले कहाँ था तू, Mayank? Your answer is correct. हाँ, Mayank, where were you, Mayank? Why you so
I
late?
was hearing.
Huh?
I was hearing.
Oh, I didn't see you, my dear Mayank. Okay. Answer is correct. Swapnil is also correct. Yes, Mayank, can you tell me how to go about this? Mayank, बता सकते हो?
Sir, to find delta V, you can substitute the values of like t in the equation in V.
So
Delta V is equal to 4 plus 4j cap minus 4j cap, which will be 4.
okay. Fine, students. When we speak about it, students, impulse is what we consider is impulse. We consider is that maximum force which acts for a very short interval of time, students. For a very short time, dt. Students, I want to go for this part of it. मुझे impulse चाहिए, students, for a very short interval of time चाहिए. तो किसी भी हाल में देखो मुझे time interval I know it from 0 seconds to 2 seconds. I know that. Do I know force? No, I don't know force. Can I find out force? Simple. Force is equal to what? Sir, is force is equal to mass into acceleration. What is acceleration? It's the rate of change of velocity. So can I say force is equal to mass, which is 2, differentiating velocity with respect to time? Now, students, what exactly differentiating 2t I plus 4j by dt? So force kitna hoga, students? This is 2 into. Students, what is differentiating 2t into I we consider? So 2 is outside, students. Okay. dt by dt will be 1 we consider in terms of I cap. And this will be how much? Differentiating 4j, but 4 is a constant, so that part will be 0. What exactly force will be equal to, students? 4I Newton. Agreed. Now can I find out the impulse? Yes, impulse is equal to what we consider. Since for a small time, students, the impulse is also very small, we need to go for. Since the impulse chota hai for small interval of time, I need to find out impulse for the total. So what do I go for? Integration of this. So integration of dj will be j. Integration of f into dt we consider another from where to, sorry, integration of f into dt will be how much? From time t equal to how much? 0 seconds to time t equal to 2 seconds. So impulse kitna hoga? Force, how much is that given to you as 4I? I'll remove it outside. Integration of dt will be t 0 to 2. So it's 4 in bracket 2 minus 0. So what's the answer? 8I. Is this clear? Sorry. Newton second. Students, for a very short interval of time, if I were to consider the impulse is very small. If I want to find out impulse for a definite time interval, students, then simply we can go for integration of it. And we got the limits 0 to 2. We found out the force also. Ashmita, is it clear?
Yes, sir. Clear.
Okay. Third one. Please solve the third one. Can I erase it? इसको erase कर दूं मैं?
Yes, sir.
Yes, Nishant. 8I. So the next question. A ball of mass 1 kilogram is attached. Students, if you happen to look at the diagram is given to you, students. A ball of mass 1 kilogram is attached to an inextensible string. Students, the string is inextensible, highly elastic, we consider, students. The ball is released from position as shown in the figure. Now, if you look at the figure, students, it's in this manner. This is the suspension part of it. The string is over here. And students, the string is made to be wound. Okay. It's kept in this manner and the ball is over here. The students, this position and this position is almost the same, I'll consider. Okay. A ball of mass 1 kilogram is attached to inextensible string, students. Is that clear? The ball is released. Students, the ball is released from its position as shown in the figure. Find the impulse imparted by the string. Find the impulse imparted by the string to the ball immediately after the string becomes taut. Students, I need to find out impulse imparted. Since impulse imparted by the string to the ball. Listen carefully, who's imparting impulse whom? By the string to the ball to the ball immediately after the string becomes taut. Immediately after string is taut. Taut का मतलब stretch tightly. यानी अगर मैं इसको loose छोड़ दूं students, तो अभी मेरा diagram क्या होगा? If in case if I show the diagram, if I release it from here, same diagram I'm trying to draw it, students. This was the position which I'm taking it over here. If I'm releasing it, now the string is stretched tightly. The length of this part is given to us 1 meter, students. This much is 1 meter. Hope the question is clear, students. G is given to you as 10 meter per second square, students. Small g is given to you as 10 meter per second square. Acceleration due to gravity. So, students, the question is: a ball of mass 1 kilogram is attached to an inextensible string. The mass of the ball is 1 kilogram. The ball is released from the position as shown in the figure. I'm releasing it from here. Find the impulse imparted by the string. Impulse imparted by the string onto the ball immediately after you release and the string becomes taut. G is 10 meter per second square. Absolutely correct, Smith. Smith has got the answer. Yes, anybody else? Yes, anybody else? Students, shall we discuss, students? Swapnil, Mayank.
Yes, sir.
सुमित बोल सकते हो कैसे करोगे?
Yes, sir. J equals to mv minus 0, as I have simply done 1 into under root 2 gh, which will give us under root 40 ns. So 2 root 10 ns.
देखा? Students, it is very easy. Students, बॉल को कैसे रखा? पहले हाथ में पकड़ के रखा हुआ ना स्टूडेंट्स. तो इनिशियल वेलोसिटी क्या है इसका? सर इनिशियल वेलोसिटी 0 मीटर पर सेकंड है. मुझे पूछा गया इम्पल्स. इम्पल्स सबको पता है. व्हाट एग्जैक्टली इम्पल्स का मतलब? चेंज इन मोमेंटम होना चाहिए, है ना? यानी मास इनटू फाइनल वेलोसिटी माइनस द इनिशियल. ये फाइनल और इनिशियल किसका वेलोसिटी? भाई बॉब का वेलोसिटी ना. बॉब यहाँ से भी नीचे गिरेगा तो उसकी इनिशियल वेलोसिटी तो 0 है. फाइनल क्या तुम निकाल सकते हो? क्यों नहीं. उन्होंने क्या पूछा? इम्पल्स imparted to the string, sorry, the impulse imparted by the string to the ball, by the string to the ball immediately after the string is taut. यानी जैसे तुम रिलीज करोगे the ball is going to have a free fall. यानी देखो, अगर ये 1 मीटर है स्टूडेंट्स, तो ये भी तो 1 मीटर है. यानी बॉल कहाँ से गिरा है? बॉल का हाइट क्या है? at what height the ball is made to fall? So the height at which the ball is made to fall is 2 meter under gravity. So can you find the final velocity of the ball? Yes, v square is equal to u square plus 2gh, है ना? इनिशियल वेलोसिटी तो 0 है, तो v क्या हो जाएगा? अंडर रूट 2gh हो जाएगा. g कितना दिया है? 10 पूछा है, तो 2 2 4 तो कितना चाहिए? 40 हो गया. 40 मीटर पर सेकेंड. क्या पूछा हमें? इम्पल्स मास कितना दिया है? मास इज 1 किलोग्राम इनटू वेलोसिटी कितना मिला है? √40. Agreed? And √40 will be equal to how much? 10 into 4. What's my answer? To √10 Newton second. Students, क्या ये clear हुआ? हाँ students?
Yes, sir.
Students, impulse is simply when see the question was given to you instantly. You said impulse पूछा है, change in momentum चाहिए या see दो चीज चाहिए, या तो change in momentum चाहिए, force into time चाहिए. Time नहीं दिया है, force नहीं दिया है. Change in momentum possible है. Bob initially rest पे है, फिर इसको release करोगे तो नीचे की तरह आएगा. And the impulse is imparted where? It's by the string onto the ball. We consider, okay, by the string to the ball. जैसे उसको रिलीज करोगे और रिलीज करोगे तो क्या होगा? स्ट्रिंग पूरा स्ट्रेच हो जाएगा टाइटली. So in that case, what is the velocity? Using the formula v square is equal to u square plus 2as. So v initial velocity is 0, so that is under 2gh हो जाएगा. G is 10, height is 2 meters. क्योंकि देखो ये 1 मीटर स्टूडेंट्स, तो ये भी लेंथ 1 मीटर है. यानी मैं ये रेफरेंस फ्रेम ले रहा हूँ स्टूडेंट्स. Look over here. I'm taking the reference frame over here. I'm taking this as my reference frame, students. So that's why the total height at which it is made to fall freely under the gravity will be 2 meters. Are you getting it, students? And it is going to cover this height as well as it's going to fall down till here. Therefore, the answer will be how much? 2√10. Can I erase this, students?
Sir,
Yeah, Bolo Smith.
sir, in J they can give the option as 2 under root G dot ns.
क्या बोल रहे हो?
सर जब जे एग्जाम में ऑप्शन में ऐसे भी दे सकते हैं ना कि 2 अंडर रूट जी 10 के जगह जी.
Yes. 10 की जगह पे g दे देंगे. Acceleration of gravity small g. Yes, absolutely correct. Gravitational acceleration की हिसाब से जा रहा है. Can I erase, students? इसको erase कर दो students अभी.
Yes, sir.
Yes, sir.
Okay. Students, please to take care for this particular chapter. We are going with a proper speed. I'm not rushing also, students. Each and every concept I'm picking it up, and all the problems, students, all unsolved problems, we are doing it from the module, students. Yes, exercise is somewhere it's your part we need to consider, but at the same time, students, you need to gain confidence. You can't lose confidence. And students, again, I'm telling you, जैसे कि तुम काइनेमैटिक्स के अंदर लीनियर मोशन के अंदर तुम सॉल्व कर सकते हो, लेकिन प्रोजेक्टर आता तो तुम फॉर्मूलाज भूल जाओगे. ग्राउंड टू ग्राउंड प्रोजेक्शन या ग्राउंड टू इंक्लाइन प्लेन के ऊपर प्रोजेक्शन, तो वहां पे तुम शायद फॉरगेट करोगे अगर तुम कंसिस्टेंसी में नहीं हो. तो सेम थिंग ये फॉरगेटफुल है स्टूडेंट्स. सीओएम, सेंटर ऑफ मास, कंसेप्ट एंड सिस्टम ऑफ पार्टिकल्स, ये वाला टॉपिक भी बहुत स्टूडेंट्स को ट्रिकी लगता है, लेकिन जो स्टूडेंट्स कंसिस्टेंसी में प्रैक्टिस नहीं करते, दे आर गोइंग टू हैव अ टफ टाइम. आई एम वार्निंग यू वेरी क्लियरली, स्टूडेंट्स. So all the time, go on consistently practice, students. Don't leave it off. And this becomes the basis to understand your rotational motion, students. So the next topic after this will be rotational motion. That's where you pick up system of particles, students. And many of the concepts have been picked up from laws of motion itself only. Now the next part which I'm going to pick it up will be collision. Students, collisions तुम लोग ने नहीं किया होगा ना, students? Students, have you learned collisions in laws of motion? नहीं किया ना, students? की किया है? हाँ, students?
The collision of linear momentum of two bodies हुआ था.
अच्छा, so that is head on. तो वहाँ पे इलास्टिक इनइलास्टिक के बारे में कुछ बोला था सर ने?
No, sir.
Okay, fine. तो हम वही चीज पकड़ेंगे स्टूडेंट्स. वी आर ट्राइंग टू गो फॉर हेड ऑन कोलिजंस इन दैट केस. लेकिन कोलिजंस पहले हम जाएंगे स्टूडेंट्स स्प्रिंग मास बॉडीज के लिए. स्टूडेंट्स, कोलिजन का मतलब क्या होता है? व्हेनेवर देयर इज अ फिजिकल कांटेक्ट बिटवीन टू ऑब्जेक्ट्स, स्टूडेंट्स, that is one thing which normally a student try to think. Collision ka matlab, it can be having an impact of one body with respect to another. That is called collision. That's what, if a question is raised, many of the students will answer that. Like students, in physics, we can't say necessarily that this is also it should be a physical contact between the two bodies. Now, for example, if I say, if I take one block and students, there is another block. Both the blocks are placed on a horizontal student surface, a frictionless surface, students, and both of them are connected by a highly elastic spring. Can there be collision between these two masses also? Why not? There can be collision between these two masses also. Why not? तो यहाँ पे भी स्टूडेंट्स कोलिशन होता है, लेकिन यहाँ पे फिजिकल कांटेक्ट नहीं होगा स्टूडेंट्स, यहाँ पे फिजिकल कांटेक्ट नहीं आता है। यहाँ पे when the two masses come to the nearest approach, listen carefully, जब भी दोनों masses when they come to the nearest approach where the compression is minimum, students, we say that instant the bodies has undergone collision, लेकिन there is no physical contact. तो समझ में आ रहा है स्टूडेंट्स? फॉर एग्जाम्पल, अगर ये मैंने m1 लिया है, ये m2 लिया, स्टूडेंट्स ये सोचो कि मैंने ये m1 को मैंने स्पीड दे दिया u1, इसको मैंने दे दिया स्पीड u2, ये भी इस तरफ जा रहा है, ये भी इस तरफ जा रहा है, क्या होगा? और मैंने बोला u1 is greater than u2. Students, what's going to happen? Students, can I say after certain time, students, don't you think so that the two bodies will certainly come closer to each other, and that will be the maximum compression of the two blocks, है ना? ये maximum compression होगा. This is m1 and this is m2. Students, if u1 is greater than u2, then this body will slide with a greater speed. This is going further ahead with a lesser speed. Lekin at a certain instance, students, your m2 will be very close to m1 in that case, and that is we call it at the instant of maximum compression. Students, जब भी maximum compression होगा, यानी जब ये m1, प्लीज पे अटेंशन स्टूडेंट, जब ये m1 m2 की तरफ जाता रहेगा तो u1 का स्पीड, u1 will go on decreasing because it is getting a restoring force. The spring is getting compression. Students, the velocity of u1 will certainly go on decreasing, students. In this case, we consider in that case, the velocity of u1 will be certainly decreasing, we take it. Lekin at maximum compression, students, at maximum compression, what is going to happen to the two bodies? Students, your u1 decreases till it reaches to maximum compression. At maximum compression, students, the speed, listen carefully, of the two blocks, the speed of the two blocks, students, becomes exactly equal. यानी at maximum compression, students, ध्यान से सुनना, अगर मैंने v1 लिया है पहले वाले का वेलोसिटी, दूसरे का वेलोसिटी अगर मैं v2 बोलूं तो v1 will be equal to v2 और उसको मैं v लिख सकता हूं. Students, initially it's going closer and closer and closer. जैसे जैसे वो compression होता रहेगा तो उसकी velocity change होगी. So now what happens? u1 will go on decreasing. It will form into v1, students. I getting it? And the body m2 will have v2, but they will not be same. Lekin at maximum compression, I can say v1 is equal to v2 and that is equal to v. After maximum compression, what's going to happen? Friends, at maximum compression, what happens? Then you say, sir, there's a strong internal restoring force acting. Students, you all have learned about spring mass. Spring mass किया हुआ है, students. तो यहाँ पे क्या होगा? सर, एक maximum restoring force act हो रहा है at maximum compression. So उससे होगा क्या? उससे होगा क्या? So उससे ये होगा कि ये जो m1 है, this m1 and m2 now will start moving in the opposite direction, students. m1, m2 will now start moving in opposite direction, students. What is the velocity? Students, what is the velocity? v1 यहाँ पे होगा. इसकी velocity क्या होगी? v2. लेकिन क्या होगा velocity? Students, what exactly the velocity I'll consider will be? So the velocity of v1 will be certainly less than v2. क्या ये clear हुआ, students? ये कभी है after Students, after maximum compression, students, do take care. So after maximum compression, students, what happens in that case? The velocity of V1 we consider will certainly will be less as compared to that of V2, but in the direction opposite in that case. क्या ये clear हुआ, students? Students? Now can I use law of conservation of linear momentum over here? Students, law of conservation of linear momentum. So let us go for law of conservation of linear momentum, students. When after compression, तो क्या होगा, students? What is the initial momentum? So what is the initial momentum? तुम बोलोगे sir, it's m1u1 plus m2u2. What is the final momentum, students? m1v1 plus m2v2. ये हुआ तुम्हारा law of conservation of linear momentum. लेकिन ये किसके लिए? After compression. Can I use law of conservation of linear momentum at maximum compression? उसका formula अलग होगा, students. अगर मैंने पूछा what exactly law of conservation of linear momentum? Law of conservation of linear momentum at maximum compression, students. तो क्या होगा? मतलब सर at maximum compression दोनों की velocity same है. तो यहाँ पे law of conservation of linear momentum क्या होगा? So this is m1u1 plus m2u2 is equal to m1 plus m2, and both of them will have same velocity. क्या ये clear हुआ, students? Students, is it clear to all of you all?
Yes.
So students, collisions का मतलब क्या है? जरूरी नहीं there should be a physical contact between the two bodies. So please try to think in this manner कि अगर if I take a block M1 and block M2, both of them are held by a highly elastic spring, both of them are moving in the same direction, but this is greater as compared to this. So जैसे जैसे नजदीक आएगा तो क्या होगा? इसकी स्पीड कम होगी, इसकी स्पीड है बढ़ेगी. Are you getting it? But same time there is, because there is a restoring forces acting. So the speed of M1 will go on decreasing. Let us say V1. Speed of M2 be V2, but they will not be same, they'll be different. लेकिन जैसे वो maximum compression पे आएगा for a certain instant, students, at that instant of maximum compression, both the blocks will have same velocity. After maximum compression, what's going to happen? What's going to happen after maximum compression? Now the two will go in the direction opposite in that case. Agreed? So one, there will be a force of action. Maximum compression, reaction will be onto the second block. Students, reaction when it comes on the second block, V2 will have a greater velocity as compared to V1 after compression. तभी जाके स्टूडेंट्स मैंने V1 को कम कर दिया, V2 को ज्यादा रखा है, लेकिन ये कभी होगा? आफ्टर मैक्सिमम कंप्रेशन. मैक्सिमम कंप्रेशन वाले दोनों का वेलोसिटी सेम है? नहीं, अलग है. एट मैक्सिमम कंप्रेशन दोनों की वेलोसिटी सेम है. तो क्या लॉ ऑफ कंजर्वेशन ऑफ लीनियर मोमेंटम दो अलग केसेस होंगे यहाँ पे? यस. Read your question very carefully when you're solving it for spring mass object, students. Are the question asked for maximum compression or is a question asked with respect to after compression? अगर after compression होगा students तो ये तुम्हारा law of conservation of linear momentum होगा. Maximum compression के लिए both of them will go same velocity. क्या ये clear हुआ, students? Now, if in case if I happen to go for students, what exactly your mechanical energy at maximum compression, students? Going for law of conservation of mechanical energy, students. Law of conservation of mechanical energy at maximum compression, students. तो कोई बता सकता है क्या होगा? Yes, anybody can give me the formula? What is law of conservation of energy, students? So total mechanical energy is conserved. जैसे momentum is conserved, students. अगर momentum conserved है तो हम लोग ने mechanical energy भी conserve, यानी the initial kinetic energy is equal to the final kinetic energy, students. That means total energy initial is equal to total energy final. We can put in that manner, students. Total energy initial is equal to total energy final. Total energy initial में क्या होगा? Sir, ये block है जिसका mass m1 है. Is it going with the velocity? Yes. So u1 square. स्टूडेंट्स अभी मैं एनर्जी बोल रहा हूँ तो ये स्केलर फॉर्म में आएगा, यहाँ पे वेक्टर नोटेशंस नहीं आएंगे स्टूडेंट्स। जब भी तुम लॉ ऑफ कंजर्वेशन ऑफ लीनियर मोमेंटम यूज करोगे स्टूडेंट्स, तो प्लीज यूज वेक्टर नोटेशन, साइन कन्वेंशंस विल बी मस्ट। They will tell you about the direction of motion of the object in that case. अगर आफ्टर कोलिजन आफ्टर कंप्रेशन के बारे में देखूंगा तो v1 मेरा नेगेटिव होगा, v2 मेरा पॉजिटिव होगा। पहले केस में u1 और u2 दोनों पॉजिटिव है, वो तो तुम्हारा अलग पॉजिटिव एक्सेस। So please take care while solving questions onto this. Read your question very carefully, categorize, is it for maximum compression or is the problem after compression? Is energy conserved in both the cases? Yes, we can consider. लेकिन यहाँ पे तुम्हारा final energy may not be equal to the initial in that case. There will be change because the velocity is different in this case. यहाँ पे क्या होगा, total energy initial energy किसका होगा सर, half m1 u1 square। second block के लिए कितना होगा, half m2 u2 square। what is the final energy, total energy? सर दोनों का velocity v1 और v2 दिया हुआ है, are you getting it? और किसके लिए चाहिए मुझे, at maximum compression चाहिए students। I want the answer for what, maximum compression, not after compression students। तो मैक्सिमम कंप्रेशन के लिए क्या होगा सर, दोनों की वेलोसिटी सेम है v, तो यहाँ पे क्या होगा, हाफ m1 plus m2 into v square students। but at maximum compression can I say the spring has undergone maximum compression, so it has stored some which energy, sir, over here there is elastic potential energy also stored into it। so can I use elastic potential energy, half a x square, this is maximum compression, x max, and this becomes your conservation of mechanical energy at maximum compression students। total energy initial is equal to total energy final, initial half m1 u1 square, half m2 u2 square, final at maximum compression will have same velocity, and this is the maximum compression x, and elastic potential energy is half a x square। Students, have you all come across this formula half a x square students? Students, ये पढ़ा है कि नहीं पढ़ा स्टूडेंट्स, लॉज ऑफ मोशन में स्प्रिंग फोर्सेस के अंदर या वर्क पर एनर्जी के अंदर स्टूडेंट्स, फॉर्मूला W spring, what is W spring? Swapnil, what is that? No, I didn't get you. I didn't get you, Swapnil. Acha, work. Okay, you have done it in work part now. Students, have you all done it? Ye clear hua, students? Have you all clear? Is this part clear to all of you all?
Yes, sir.
What about others? Mayank?
Yes, sir.
Okay. Nishant? Swapnil? Okay. Aisha? Ashmita? Ashmita, is it clear? He's not there. Okay, students. Can I erase it, students?
Yes, sir.
Students, क्या मैं erase कर सकता हूँ? Fine. तो ये ध्यान रखना students. ये कौन सा फॉर्मूला है, half k x square students? This is what we consider is the elastic potential energy which is stored in the spring students. So now when you do problems, do take care of these kind of questions students. So collision का मतलब जरूरी नहीं है students that it should have a physical contact. It can be for two masses held by an elastic spring. Okay, students, when the two masses are brought very close to each other at their maximum compression also, we can call their condition for approach. So we can call that to be as a kind of collision at the condition of approach students. Students, if in case if I say elastic potential energy, a simple concept on that, students, elastic potential energy का formula क्या है students? Elastic potential energy half k x square, है ना? Students, ये ध्यान में रखना, k क्या है? Students, k is spring constants. K is called as spring या elastic या फोर्स कांस्टेंट स्टूडेंट्स? Agreed. And this is actually considered with respect to restoring force. Students, restoring force is equal to negative kx. ये तुम्हारा formula है. Students, अभी एक simple gesture में दे रहा हूँ students, because many students क्योंकि ये इसके related भी questions आते हैं intermediate. You should not get any kind of problems while solving it, students. For example, students, अभी ये सोचो कि एक rigid support है students, और ये horizontal surface है, और ये block है students, ये block है. ये ब्लॉक को मैंने अटैच किया विद हाईली इलास्टिक स्प्रिंग. प्लीज पे अटेंशन स्टूडेंट्स, ये मीन पोजीशन. ओके, अभी ये मैं ब्लॉक को पीछे की तरफ खींच रहा स्टूडेंट्स. मैंने ब्लॉक को अगर पीछे की तरफ खींचा तो क्या होगा? स्प्रिंग स्ट्रेच होगी कि नहीं होगी? हाँ. अगर मैंने ब्लॉक को यहाँ पे लिया, सोचो मैंने ब्लॉक को यहाँ पे लिया तो कहने से स्प्रिंग एकदम स्ट्रेच हो जाएगी स्टूडेंट्स. स्प्रिंग स्ट्रेच हो जाएगी. अगर स्प्रिंग स्ट्रेच होगी तो व्हाट हैपेंस? as applied force increases students, एक और फोर्स एक्सर्ट हो रहा है ना, रिस्टोरिंग फोर्स, इक्वल एंड मैग्नेट ऑपोजिट इन डायरेक्शन, है ना? रिस्टोरिंग फोर्स इक्वल एंड मैग्नेट ऑपोजिट इन डायरेक्शन. तो ये जो हम रिस्टोरिंग फोर्स लेते हैं स्टूडेंट्स, वो किसके ऊपर डिपेंड हो रहा है? स्टूडेंट्स, रिस्टोरिंग फोर्स डिपेंड होता है डिस्प्लेसमेंट के ऊपर. तो जितना जितना मैक्सिमम कंप्रेशन उतना मैक्सिमम रिस्टोरिंग फोर्स. तो जब भी ध्यान से देखना स्टूडेंट्स, जब भी M1 M2 की तरफ जा रहा था, हेलो, M1 M2 की तरफ जा रहा था, समझ में आ रहा है? क्योंकि मैंने U1 ग्रेटर देन U2 बोला था, तो हम ये सोचेंगे M2 भी मोशन में है, स्प्रिंग एक्शन है, M1 M2 की तरफ जा रहा है, तो मेरा फोर्स ऑफ एक्शन इस तरफ जा रहा है स्टूडेंट्स. फोर्स ऑफ एक्शन इस तरफ जा रहा है, तभी इसकी स्पीड कम होती जाएगी. Are you getting it? This will try to have some speed which is greater. Are you getting it? At maximum compression क्या होगा? V1 is equal to V2, that is equal to V. लेकिन उसके बाद में क्या होगा? To every action there is an equal and opposite reaction. ये reaction force कौन create कर रहा है? M2 on M1. And that will give enough velocity to V2 in this direction and V1 in the direction opposite. But in this case, your V1 will be less than V2. And that is what we consider for spring action. Hope this part is very clear, students. Based on that, you should use your vectors. क्योंकि momentum के problems करोगे ना students, law of conservation of linear momentum के लिए problems करोगे ना spring action में, तो vectors को ध्यान में रखना, sign conventions को ध्यान में रखना, किस तरफ जा रहा है ऑब्जेक्ट को, तो तुम्हें प्रॉब्लम सही मिलेंगे. दूसरी बात, अब यहाँ पे मैक्सिमम कंप्रेशन या मैक्सिमम एक्सपांशन स्टूडेंट्स, ये कहाँ से आता है? तो रिस्टोरिंग फोर्स डिपेंड्स ऑन द डिस्प्लेसमेंट, लेकिन रिस्टोरिंग फोर्स का डायरेक्शन डिस्प्लेसमेंट से ऑपोजिट होगा, तो माइनस kx आ गया. के का मतलब क्या है? स्प्रिंग कांस्टेंट, इलास्टिक कांस्टेंट, फोर्स कांस्टेंट. वो किसके ऊपर डिपेंड होता है? के किसके ऊपर डिपेंड होता है? मटेरियल के ऊपर डिपेंड होता है भाई. नाउ फॉर एग्जांपल, स्वप्निल और स्मिथ दोनों एक्सपेरिमेंट परफॉर्म कर रहे हैं, लैब के अंदर कर रहे हैं, लेकिन लैब असिस्टेंट ने स्वप्निल को एकदम न्यू ब्रांड स्प्रिंग दे दी, और स्मिथ को 3 साल पुरानी वाली स्प्रिंग दे दी. तो किसमें इलास्टिसिटी ज्यादा होगी? जो नई वाली स्प्रिंग होगी, तो वहां पे की वैल्यू अच्छी होगी, की वैल्यू ग्रेटर होगी, तो वहां पे बॉडी विल एबल टू हैव अ स्ट्रॉन्ग रिस्टोरिंग फोर्स, इफेक्ट ज्यादा अच्छी तरह से होगा. I getting it? That's the meaning of K we consider. Now if I want to go for elastic, let us say that the spring has undergone an extension. So अगर मैं बोलूं कि spring को मैंने extend किया by dx, force applied is F. So what is the work done? Friends, what is the work done for this applied force? Work done will be equal to what? Applied force into displacement, because I'm pulling it. Since it's a dot product, applied force and displacement same direction में है, तो what exactly cos of 0 will be 1. तो ये force applied into displacement होगा. लेकिन students, can I say applied force and restoring force are equal in magnitude and opposite in direction, है ना? तो जितना तुम ब्लॉक को इस तरफ खींचोगे, जैसे तुम्हारा अप्लाइड फोर्स बढ़ रहा है, तो रिस्टोरिंग फोर्स भी तो बढ़ रहा है ना, इक्वल इन मैग्नेट ऑपोजिट इन डायरेक्शन. तो क्या मैं वर्क डन का फॉर्मूला डाल सकता हूँ यहाँ पे? यस, डाल दो. ये देखो, वर्क डन का फॉर्मूला क्या होगा सर? अप्लाइड की जगह पे माइनस एफ आर डालो, इंटू डी एक्स आ जाएगा. व्हाट इज रिस्टोरिंग फोर्स? माइनस के एक्स आपने बोला है फॉर्मूला सर, तो यहाँ पे वर्क डन का फॉर्मूला क्या हो जाएगा? माइनस एफ आर इंटू माइनस के एक्स. तो माइनस इंटू माइनस क्या हो जाएगा? प्लस के एक्स इंटू डी एक्स हो गया. एग्रीड? But are we trying to find out work done for the small displacement or total displacement from mean position? Yes. For maximum displacement, let me take it from x is equal to 0 to capital X. So go for integration. Go for integration 0 to capital X. What is integration of dw? K spring constant hai, cannot be integrated. What is integration of x into dx? आ गया x square by 2. Lower limit is 0, upper limit is capital X. So what's the formula for work done? Half kx square. Students, this is work done. Work done in either stretching the spring or compressing the spring. This work done gets stored in the spring. This work done gets stored in the stretched spring or compressed spring in the form of which energy? Elastic potential energy. Students, तभी जाके हम बोलते हैं elastic potential energy का formula क्या है? Half kx square measured in joule.
So that would be half minus half kx square.
Pardon?
That will be minus half kx square.
No, my dear, it's plus kx square. Restoring force क्या है? Restoring force is minus kx है ना?
Okay.
तो restoring force की जगह पे minus kx डाल दिया, minus into minus plus हो गया, तो kx into dx.
Yes, yes.
One student, work. मैं block को इस तरफ खींच रहा हूँ. Look at my hand, students. Where is my force applied is going right hand side? Is the displacement of the block is also on the right hand side? तो कहने से applied force और displacement एक direction में होंगे तो cos of 0 1 हो जाएगा. यहाँ पे, हाँ, work done due to applied force. ये clear हुआ?
Yes.
हाँ students. फिर क्या मैंने बोला? अप्लाइड फोर्स और रिस्टोरिंग फोर्स दोनों ऑपोजिट डायरेक्शन में है, इक्वल इन मैग्नीट्यूड ऑपोजिट डायरेक्शन. तो अप्लाइड फोर्स की जगह पे मैंने रिस्टोरिंग डाल दिया माइनस एफ आर. लेकिन एफ आर का फॉर्मूला क्या है? माइनस के एक्स. तो माइनस इंटू माइनस प्लस के एक्स आ गया, के कांस्टेंट आ गया तुम्हारा इलास्टिक पोटेंशियल एनर्जी. स्टूडेंट्स, क्या क्लियर हुआ स्टूडेंट्स? इज इट क्लियर टू ऑल ऑफ यू ऑल?
Yes, sir.
So students, do keep in mind that when you're speaking about collision, students, for spring mass object students, do keep in mind that when the bodies or the objects are placed on a horizontal surface, students, it depends on the speed. Are you getting it? Momentum can be conserved, kinetic energy also we can say it's conserved, but there can be loss of kinetic energy, but linear momentum is always conserved, we consider. But at maximum compression, students, and at maximum extension, whether maximum compression or at maximum extension, students, the velocity of the two objects will be exactly the same. Initial u1 greater than u2 tha. At time of compression, both of them will have same velocity, students. After compression, v1 and v2 ka direction will change. v1 increase ho jayega, or v1 will be less and v2 will increase, but in the direction opposite. When you go for total energy, students, total energy before and total energy final में students तुम्हारा spring का भी energy आएगा. भले वो compression के बारे में होगा, expansion के बारे में, तो दोनों केस के अंदर half के x square आएगा. जहाँ पे x हो सकता है maximum compression, x हो जाता है maximum elongation. Students, can I erase this part, students? Students, can I erase it?
Yes, sir.
Okay. Swapnil, clear है Swapnil?
Yes, sir.
Okay. Smith, what about you?
Yes, sir. Clear.
Nishant, Mayank, those who reply, Ashmita, I don't know, Ashmita, she has gone out, she tried to enter in, is she there? Ashmita, are you there?
Yes, sir. Clear. Yes, sir.
कहाँ चले गए थे बीच में?
Sir, my network issue, sir.
Okay, fine. यानी अश्मिता, collision का जरूरी नहीं है कि there should be a physical contact. जो तुम लोगों ने किया था वो physical contact वाला था, वो भी हम करेंगे. हमारे में जो collisions होगा वो actually carried from the laws of motion का ही है, जहाँ पे हम head-on collisions करेंगे. That I'll pick it up tomorrow in the next lecture, students. हेड ऑन कोलिशन है, और वो हेड ऑन कोलिशन के अंदर इलास्टिक एंड इलास्टिक कोलिशन होगा और ऑब्लिक कोलिशन होगा, और वहां पे डिफरेंट केसेस हो सकते हैं. So we'll be going for those kind of different cases. And in two types of collision, students will consider for spring mass and we consider for two objects which are not connected by any spring. We consider. So students, when you speak about types of collisions, students, type of collisions can be classified in two manners. Students, अगर मैं एक simple theoretical approach दूँ collision का, the types of collision students can be of two we consider. एक होता है elastic collision students, एक होता है head-on collision. स्टूडेंट्स, ये इलास्टिक कोलिशन के अंदर मोमेंटम और एनर्जी दोनों कंजर्व होती है इलास्टिक कोलिशन के अंदर. आई गेटिंग इट? जहां पे बॉडी का ओरिजिनल शेप और साइज कभी चेंज नहीं होता है, यही ध्यान में रखना. दूसरा, इन इलास्टिक कोलिशन के अंदर स्टूडेंट्स बॉडीज आफ्टर कोलिशन डू नॉट रिटेन द ओरिजिनल शेप एंड साइज. स्टूडेंट्स, उसके अंदर बॉडी एक दूसरे के साथ में कोलाइड होने के बाद में दे गेट इंटैक्ट, दोनों साथ में चलना शुरू कर देते हैं. फॉर एग्जाम्पल, अगर दो ऑब्जेक्ट्स कोलाइड होते हैं, दो गाड़ियां कोलाइड होती है, तो उसके बाद में एक गाड़ी दूसरे को खींचते हुए लेके जाती है. आई गेटिंग इट? सपोज अगर पीछे वाली कार आगे वाली को कर लेता तो इट विल स्लाइड अलोंग विद इट. द कांटेक्ट बिटवीन द टू ऑब्जेक्ट्स रिमेन्स फॉर अ सर्टेन टाइम. आई गेटिंग इट? सो इन दैट द बॉडीज आफ्टर कोलिशन डू नॉट रिटेन द ओरिजिनल शेप एंड साइज. स्टूडेंट्स, यहाँ पे मोमेंटम इज कंजर्व्ड बट एनर्जी इज नॉट कंजर्व्ड. This I'm speaking about students for those which are having physical contact students. दूसरा तुम्हारा जो हेड ऑन कोलिशन के अंदर है स्टूडेंट्स, यहाँ पे तुम्हारा ऑब्लिक कोलिशन भी आता है. आई गेटिंग इट? जब भी तुम्हारा हेड ऑन कोलिशन होगा ना स्टूडेंट्स, ये ध्यान में रखना, डायरेक्शन ऑफ कोलाइडिंग बॉडीज का जो वेलोसिटी होगा स्टूडेंट्स इज ऑलवेज अलोंग द लाइन ऑफ इम्पैक्ट. हमेशा ये ध्यान में रखना, जब भी एक बॉडी को दूसरे बॉडी से कोलाइड करता है तो उसको हम बोलते हैं लाइन ऑफ इम्पैक्ट, लाइन ऑफ कोलिजन. Students, after collision, the velocity can be considered in the same line. The velocity of the bodies after collision will be along the line of impact. Yeah, along the line of collision. ये बहुत important point है to understand vector forms after collision, students. तो हमेशा ये ध्यान रखना students. दूसरा तुम्हारा oblique collision के अंदर students. यहाँ पे द कोलाइडेड ऑब्जेक्ट कौन से भी डायरेक्शन में जाते हैं, दे मूव इन द डायरेक्शन स्टूडेंट्स डिफरेंट फ्रॉम द लाइन ऑफ एक्शन. यानी अगर कोई ध्यान से सुना स्टूडेंट्स, अगर मैंने ये एक बॉडी दिया है और ये दूसरा बॉडी दिया है और ये बॉडी इसको कोलाइड हो रहा है स्टूडेंट, तो ये हुआ तुम्हारा लाइन ऑफ इम्पैक्ट. तो आफ्टर कोलिशन इनकी जो वेलोसिटी होगी वो डायरेक्शन विल बी ऑलवेज ऑन द लाइन ऑफ इम्पैक्ट. लेकिन अगर ऑब्लिक कोलिशन के अंदर आया स्टूडेंट्स, तो ध्यान से देखो, ये अगर मैंने ऑब्जेक्ट ऐसा दिया है और मैंने ये दूसरा ऑब्जेक्ट दिया स्टूडेंट्स, आई गेटिंग इट? दिस इज वन. तो ना इफ आई से लाइन ऑफ इम्पैक्ट यानी ये हुआ स्टूडेंट्स, क्योंकि जैसे ये बॉडी मोशन में आएगा, ये रेस्ट पे या ये भी मूविंग में, सपोज इसकी स्पीड मैंने बढ़ा दी, इसकी स्पीड इससे ग्रेटर है, u1 इज ग्रेटर देन u2, तो ये इसको कोलाइड करेगा ना. लेकिन इनका सेंटर ऑफ मास देखो अलग अलग पोजीशन पे है, इनका सेंटर ऑफ मास एग्जैक्टली लाइंग ऑन द सेम लाइन. तो ये क्या होगा, इसका जो टॉप पार्ट है वो इसको हिट करेगा. तो ये हुआ तुम्हारा लाइन ऑफ इम्पैक्ट, लाइन ऑफ कोलिजन. स्टूडेंट्स, ये है लाइन ऑफ इम्पैक्ट, लाइन ऑफ कोलिजन. लेकिन कोलिजन के बाद में क्या ये दो ऑब्जेक्ट उसी लाइन में जाएंगे? नहीं. आफ्टर कोलिजन इसका डायरेक्शन इस तरफ हो सकता है, इसका डायरेक्शन इस तरफ आएगा. लेकिन यहां पे आफ्टर कोलिजन दे विल गो अलोंग द लाइन ऑफ इम्पैक्ट. क्या ये क्लियर हुआ स्टूडेंट्स? हाँ स्टूडेंट्स.
Yes.
So students, we have your two types of collision, your head-on elastic collisions we consider, okay, and your inelastic collisions. It's mathematical formula, students, that I'm going to pick it up tomorrow in the next lectures. Tomorrow morning we have the sessions, no, students?
Yes, sir.
Okay, so please see to that you have a proper sleep. Don't be drowsy or sleeping in the morning hours, because we'll be solving numericals also simultaneously. Okay. So just I've given you the theoretical part of it. This I'll just state it again in the morning hours, and we'll be going for certain mathematical formulas, derivations of few, and then we'll go for problem solving. Okay. Next lecture will continue further, students.
Thank you, sir.
Yeah.